Welcome! In this session we will learn about abstraction. We have previously made these three classes shape, rectangle and triangle. And all of these have this function named area that is calculating area of the respective class. For example, rectangle class has an area function that calculates area for rectangle. And triangle class has an area function that calculates area for triangle. Now, if we make this class public and other people can use this by making its object, what they will do here is they will make the object and call this area function on their objects. Now the person who is calling this area function on the object is unaware of how we are achieving this area there, how we are calculating it. So we are hiding this internal detail from outside world. So people are unaware that how we are calculating this area. So now here when a person calls rectangle.area, he is only concerned with the results. He is creating an object here with the values and now he wants the area. As long as that area is calculated correctly, he has no concerns with the internal functionality, that how we are calculating and achieving these results. Similarly, with the case of triangle, when a person makes a triangle object and it calls an area function on triangle, as long as the results are correct, they are not concerned with the internal functionality. So we are hiding this internal functionality here in both of these area functions, that how we are calculating this. We are using this width and height variable that can be of some other name as well. We may use W and H here instead of width and height. So the person who is making object is not concerned with that. By doing this, we are hiding this internal details from user. So this is called abstraction, that we are only showing those functions to user, the name of function to user that he can use to achieve his target. As area is a name of function that the user only needs to know to calculate area, and he should be unaware of this internal functionality. So this is called abstraction, and this is a very useful concept. Suppose we have a class math and there is a function named factorial in that. So to calculate factorial, we may be using any type of code. We will be using a few steps to calculate factorial, but user needs not to know about those. Similarly, in the case of car, if we have an acceleration function, user needs not to know about acceleration function details. The only thing he needs to know about is acceleration function name. So another benefit of this is that while we are only giving the name of the function, we may change this functionality afterwards, and that will not make any changes on user side. For example, initially we gave this class to public that they can make its objects and use it, and later on a lot of people use this function area by making an object of this. Now we later on decided after a few years that we will be calculating area with some different functionality. So we change the code inside of this function. Now on our side there are changes, but on user side there is no change because they were calling this area function, and still they are calling this area function as long as we do not change the name of this function. So area function has same name but with different functionality. We can change the functionality later on. We can achieve results by using some other algorithm or something like. This is an example of area, but there you can think of big codes where we have complicated functionalities. Suppose we have an algorithm for sorting, and later on after a few years we have a better algorithm for sorting. So what we need to do? We need to simply change the code inside of that function. And on user side, the person who is using it, there are no changes because they are using these names, area and any other name of that function that we are giving in our class. So that is a benefit of abstraction, that we hide internal details from outside world. So that's all from this session.